Hello folks. So in this video, I'm going to explain square root transformation to cater two objectives again. So number one objective is of square root transformation is also to treat outliers by doing this square root transformation instead of just dealing those outliers. Deleting those outliers. So reason of not deleting the outliers is that sometimes these outliers can be novel and are helpful in nature. That is, outliers which are judged to be good data rather than doing any damage to the data or causing any issues in the machine learning predictions, right? Secondly, if we have positively or right skewed data, then we can use a square root transformation to make data which is normally distributed. So please watch this video till the end to get the complete understanding of it. Folks, this is Nitin welcoming you to the AI University channel where you can learn all your favorite digital technologies like machine learning, deep learning, AI, big data, Hadoop, virtual reality, and cloud computing. And you can acquire these related skills in order to advance your career in these fields. This channel takes on hands-on approach to build AI-based products and applications. So if you are new to this channel, consider subscribing to our channel. And if you're already subscribed, then click on the bell icon to receive the notifications about the hottest technologies of 21st century. So in the previous videos, I covered numerical techniques concerning outlier detection and treatment using methods such as z-score, interquartile range, and log transformation. As a part of outlier detection, as well as making our data normally distributed, we make use of statistical techniques like log transformation, inverse transformation, square root transformation, etc. So from a parametric statistics perspective, it's a data scientist's dream that they always get data which is normally distributed so that they can build near perfect machine learning models, but that's not the case always. We generally utilize methods like skewness or kurtosis to see if the variables or data is normally distributed or not. Square root transformation is also used when we have positively skewed variable or data. That is, when we have data which is highly skewed to the right hand side. Square root transformation is a transformation which has a moderate effect on distribution shape. Okay, if you don't know about skewness, then please watch the video given in the I button above. Okay, where I have briefly covered the skewness topic. The square root transformation is weaker than the logarithmic and cube root transformation. It is also used for reducing a right skewness, and also has the advantage that it can be applied to zero values. Okay, log transformation cannot be applied to zero values, but square root can be applied to zero values. So it is commonly applied to counted data, especially if the values are mostly rather small. Okay, so as mentioned previously, we have another transformations as well at our disposal, such as inverse transformation, square root transformation, cube root transformation, square transformation, etc. So please note that positive or negative skewed data interfere with running a parametric statistic, right? So let's take a closer look at the data first. Okay, so let me open the Excel sheet. So this is our data here for square root transformation. Again, I have three variables here. Okay, negative skewed column, then positive skewed column, as well as we have normally distributed column. And right underneath, you can see all the data associated with these columns. Okay, you can also see the associated curves as well here on the screen. So for positive skewed column, you can see the positive skewed curve, which has a tail on the right hand side. For negative skewed data, we have a negative skewed curve which has tail on its left hand side, and for the normally distributed data we can see that it is a symmetric curve, right? So for here for square root transformation, what I did was I just copied the data I used in this log transformation here. Okay, so this was the log transformation data. So I copied this data here. Okay, and added zeros here in the beginning and at the end. Okay, so at the end of the data, I added zeros for these two columns. Okay, and as well as at the beginning of it. Okay, and the reason being because I just wanted to show you that the square root transformation is very has an edge over a log transformation when it comes to the values pertaining zeros. So if we have data such that it has zeros in it, or data set which has a column which has zeros in it, then we can make use of this square root transformation. And as stated earlier, we cannot apply log transformation if we have columns where the some of the values are zero. Okay, so now let's see the code to perform square root transformation on positive skewed data. But before moving forward, I just wanted to let you know that I created data for negative skewed and normal transformation, normally distributed data. Here is that I just wanted to show you the shape of skewed data, okay, as well as make you understand how when to apply these transformations. Otherwise, there was no need to use the negative skewed data and normally distributed data here, because we applied the uh, log transformation on positive skewed, and similarly we are applying log square root transformation on positive skewed data only. So that was just for your from your understanding purpose. I include these two columns as well: normally distributed data and negative skewed data. Okay, so let's move on to the Jupyter notebook. So here on the Jupyter notebook, first in the first cell, we imported the necessary libraries like pandas, numpy, and cbond, and then I manually copied and pasted all the data here. Okay, in this particular section. So I manually copy pasted positive skewed variable values here, okay, and which has zeros in it. Then I created a data frame here in this particular section, okay, uh, data frame with a column name positive skewed, okay, and lastly I printed the data frame. So when I printed, we can see that the values are listed here. Okay, so in the next cell, what I am doing is I created a box plot to see the outliers, and we can see that there are again three outliers shown here. Okay, so these are three outliers: one, two, and three. Right. So the number one, uh, uh, as I told you earlier, we have two objectives, and the number one objective is to treat the outliers, as well as the second one is to convert the right skewed data to normally distributed data. So in the next cell, I created the input data from data frame 2 on variable positive skewness having input value ranging from 0 to, so let me show you. So before moving with that, I created this plot. Okay, just wanted to show you the shape of the data, so you can very well see that we have the right skewed data. Okay, so first graph shows you the outliers, okay, and the second one shows you the distribution shape here. Okay, and it is very well right uh, or positive out skewness graph. Okay, so right skewed or positive skewed graph here. And as I mentioned earlier, I just created the input data or input array here from this data frame 2. Okay, so I just copied the data into this new array, which is input array 2, just because I wanted to keep the original data intact. Just that's why I just copied it. Otherwise I could have utilized it, utilize this original data set also. So you can see the same data here also. Okay, and in the next section, I applied square root transformation, okay, by using a numpy's function sqrt here. Okay, so I applied this square root transformation on the input data here, And you can see when I applied this square root transformation, the values has been changed. Okay, so you can see the values are ranging from 0 to 11 something. Now in the next cell, I again created this box plot, and our first objective was to basically treat the outliers, right? So now in this cell, I'm just treating the outliers, and we can see that. And here what I'm doing is I just created the box plot on the transformed data, which is this output array 2, and this is the transformed data. You can see here I transformed the data and stored the values in the output array 2, out array 2. Okay, so these are the transformed value. Out array 2 contains the transformed value, and now I am creating the box plot on this transformed data. And as we can see that there were three outliers earlier. Now we have only two outliers. Okay, so only two outliers are visible here after doing square root transformation. Okay, and uh, this has happened because we applied the square root transformation. So one outlier basically treated using square root transformation. Okay, but again, you can see that not all of the outliers were treated very well. So that's why I mentioned in the beginning itself that this is the moderate kind of transformation. Log transformation is the strong transformation, but square root is the moderate transformation. So that totally depends upon the kind of data you have. And it only treated just one outlier. So that is one thing to consider here. Okay. So in the next cell, I have created the line graph again, okay, on the square root transformed data, and we can see that data is kind of right skewed still, right. Even after applying a square root transformation, the data is still some rightly or right or positive skewed data. Okay, kind of fairly close to normal distribution, but not perfectly you know perfectly normally distributed data, as we can see here, right? So this is the thing to consider here. You can the choice is yours. The kind of data you have, you can apply the transformation as per your needs. But again, as just to repeat, square root transformation is not the strong transformation. It's kind of a moderate transformation. Whereas log transformation is the strong transformation, and that's why the graph was near to normally distributed data, and all the outliers were also treated in the log transformation, which has been covered in the separate video. So I created a separate video for log transformation, and you can very well see that video, and I have given the link on the I button above. Okay, so I will in the upcoming videos I will show you the techniques to transform the negative skewed data as well. So we performed a log transformation and a square root transformation on positive skewed data, but in the upcoming videos I will cover the transformations for negative skewed data, and I will cover a specific technique to do that. So folks, this is it for this video. To conclude, I explained about square root transformation to treat the outliers mathematically, as well as transform positive skewed data to normally distributed data. So let me ask you a question from today's video. Can we perform square root transformation if a variable or column has zero values? Please post your comments in the comment section given below so that I can get a chance to incorporate your feedback. And you can also ask your technical questions in the comment section. I will be glad to answer your questions. And if you're watching this video and you're not already a subscriber to our channel, consider clicking that little subscribe button. And in case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me, guys. I will be covering next topic in the upcoming videos. So keep on watching. Thank you.